G'day, my name is Stephen Seefeld, and in this tutorial we're going to be making a gemstone. So before we can do that, of course, we need to know what a gemstone looks like. So let's load up our trusty Google, and we're going to be looking up faceting diagrams. Now, a faceting diagram is basically just a blueprint used by gem cutters to build the gems from the stones, to actually cut them out of the rock. We're going to use the United States Faceting Guild, but there's literally thousands of these websites. I particularly like the format that the images come in on this site. Rockhounds is another really good site because they actually have photos of the gems, so it's a lot easier to get your rendering sorted. Okay, we're going to do a simple diamond. We're going to use the lowboy source, and you might note that we're inside the brilliant cuts, standard brilliance. Now, a brilliant cut just means that the cut is designed to refract light out of the gem, basically make it nice and shiny. So jewelry, that's what a brilliant cut is, unless you've got, you know, like a ruby or an emerald, which is designed to actually trap light inside it and bounce around heaps inside the gem to create very deep warm colours. Okay, this is also why I like the USS Faceting Guild. As you can see, it's a GIF and it hasn't got a background, so it's very simple just to use the lasso tool to cut these images out. And then by simply Controlling C for copy, Control N for new, and Control V for paste, you create a new document and it's already perfectly all sized. It takes a few seconds. Okay, I'm just going to cut out the other ones now. Okie dokie. Now, once I've done that, I'm just going to come through on all these images and I'm just going to turn the background black. This will just make it a slightly bit easier for me to see. So now that we've got our images, we just need to save them. We'll just quickly check the image size. 191 by 109. 191 width by 90 height. And 9190. So they're all perfectly sized to each other. So now that we've got our images, we just need to save them. Let's just save them out as top, bottom and side. Okay, we're done. Let's load these into Max now. Okay, we're in Max. I like to quickly just switch into world view. Now let's create two plates. So make two boxes. Make them in the top viewport. When you're creating them, this will make sure that their local axes line up to the world axis. As you can see, nothing changes by switching from world to view, which is quite a handy little trick. Okay, so it was 109 height and 191 width and no length. And this is 191 width and 190 length with no height. Okay, so here's our plates. Okay, first thing we're going to do is select both the objects and right click on the move tool. Remember, we're in the world space at the moment. This means that we can simply align things to world by right clicking on these XYZ values, and that moves everything into the 000 mark, and this is really handy when modeling, rigging, pretty much all the time. Try and work in world space is my advice. So basically this plate here is at 0, 0, 0. You see the pivot is right at 0, 0, 0. And this one here pivots in the same place. We actually want this object to be underneath this object like this. But we're not going to do it by hand. We're going to use the align tool. We're aligning it through the Z, and we're going to put it on the maximum and align the maximum point of this object to the pivot point of our target object. Long story short, it moves it right down and puts it in place without us having to do anything, and it's bang on. Okay, let's load up a material editor and just quickly load in these materials. Top, side, bottom, and now we'll just apply them to these plate objects in our scene. Now of course we want the images to show, so make sure you have the show texture button depressed. And now, as you can see, we have our plate objects. So come along into the top viewport, and let's just have a quick look at exactly what we've got here. Now what we want to do is recreate this topology, and if we look quite carefully, it's actually 3 octagons, or n-gons I should say, with a pattern connecting the vertices. So let's actually build a n-gon. Make this a little bit easier to see. Okay. So this first n-gon at the top, on the outside is the easiest one to see, and that is 1, 2, 3, 4, 8 sides, so it's 16. And voila. And you can kind of see what we're getting at here. Now, we could match this all manually to the eye, but we're working in world space, so we can just simply right click and align the center of this object to world, and it's bang on, and then we can just adjust the radius to get it into the position we want. Let's go for about 95. Now you can kind of see the point of what we're trying to do here. We're trying to make a spline where there's a point at every single vertex in our diagram. So to do this we obviously need another n-gon. We can realign it to the world. This time it is 8 sides. And voila. Let's make this 52. And once again, third n-gon, realign to world. Okay. Now this one looks a little weird, the points aren't lining up, but as you can see, it's a simple matter of rotating until the points are in the right spot. Now we can do this all manually, but just through experience I happen to know that if you rotate 22.5, an 8-sided n-gon or star or shape like that, it'll actually flatten out perfectly. So let's make this 62. Let's just hide this I'll have a look at exactly what we've done. All we've done is made 3 end bonds. To